screen. There we go. Hey folks, how you doing? Hey Derek, I don't know how long you've been here for. All right, folks. So today we're going to be covering normal distribution. So pretty much, I'm gonna see how fast I can do this in, because I'm gonna use both the graphics calculator as well as showing you folks how to do it on just the manual way as well. But before we get to that, I just want to actually share this first. And I realized this as I was going through looking for resources for this. Let me just see if this is going to work. Yes. Okay. So because a lot of you are doing level 2 for the first time, and this is something that I actually forgot to mention. So you will be getting a formula sheet at the end of year exams. So basically those three numbers that you see down there, I'm talking about these three numbers here. These three numbers here, this is for algebra, then this is calculus, and then this is your probability standard. Hey, Monofet, welcome. So what's going to happen is that you get this formula sheet, right? And then they do give you just literally one page of formulas. So you get your quadratic equations there, you get your log equations, and then just very basic calculus. It's almost pointless having this formula because most of the time you actually remember this within the first couple of weeks of doing calculus. Hey, Hudson. And then we've got this like literally half page, probability trees. That's what they are. And so that's pretty much what we're going to be covering today. So I'm going to go backwards and forwards between this table, so bear with me, and then I'll try and show you folks how to work this on the calculator as well. Okay, so having a look at my notes, where is it? Where do we want to start from? I guess we're going to kind of start from this, and I think basic idea behind normal distribution, and I do apologize if I rush through this, because it's like you once you start kind of working around it, you realize it's fairly straightforward. So one thing you have to understand is that when you're using normal distribution, you're assuming that your data is kind of spread out very evenly. Now, if I was to take a little, what do you call those little, I think they're dot plots, right? So if it's something like a dot plot, you almost kind of expecting things to have like a bell-shaped curve. All right, I'm not worried too much about skewness, just looking at the shape. So generic shape of this is kind of, there's an extra little dot there. It has a bell curve. So when we talk about normal distribution, we are always thinking about the data as distributed in the shape of a bell curve. All right, that's number one. Number two is, what else can we actually talk about it? There is an assumption with the normal distribution that it is actually symmetrical. So the reason I'm saying symmetrical is, like, imagine you have a line going right through the middle here, and this little line here is going to be known as the mean. All right, that's literally at the center of your distribution. That's all right, Ferrari. And welcome, by the way. I believe it's your first time joining. So yeah, so basically what it means is that, like, you've literally got 50% of your data on this side here, and then you've got 50% of the other data inside here. So and I want to kind of mention here, it's like, okay, so there's an assumption that we are covering almost all of the data, but there's always a trick part to this. Now, what happens is that with normal distribution, you generally tend to work with like a mean, which is the middle right there, and then you will actually have a standard deviation as well. Yes, Ferrari, we will be going through it, but I just need to kind of explain this as a concept because I'm building this as a playlist. So bear with me, or come back in 15 minutes. We'll be doing some questions, yeah? Either. So the other idea is that, like, from the mean, let's say you go 1 standard deviation, 2 standard deviation, and 3 standard deviations. So imagine it like this. So we're doing the mean plus we're going to do 3 standard deviations. Basically what that means is that the idea is that there's these numbers that they come up with, and I kind of have seen it before, and I think it's 99%. I could be wrong. Someone can correct me. Basically within, I'm sure it's 99. Is it? Must be. 99% of your data is within 3 standard deviations. Basically what that means is, I'm just going to highlight this in a different color. So that's 99% is going to be between whatever these 3 standard deviation values are. All right, so if you think about it like this, that's 1 standard deviation, 2 standard deviations, 3 SD. This is 1 standard deviation, 2 standard, 3 standard deviations. So we're literally like kind of like fanning out 3 ways, 3 standard deviations apart from the middle of the mean, right? Okay, so with that in mind, let me just see. Do we want to go straight to the questions? No, we don't want to go straight to the questions, because I need to show you guys how to actually use these tables here. Because what you'll notice is, hey Elise, how you doing? Welcome. They've got this bunch of tables here, and I mean, this is pretty much, I'm working out of the formula sheet, right? So you guys are going to get used to it. By the way, if you are using the graphics calculator, there's nothing wrong with using the graphics calculator, but they do, I've seen it like in the recent exams, they want you to show a diagram and the Z value and so on. So just bear with me for a while, and then we'll actually get through it. But what I might do is, yeah, let's actually go back here. So at the moment, I'm going to start with like really basics here, so you get the idea of how to use the table and the calculator. And then after that, we'll kind of see how you guys are coping, and then from there we'll actually decide whether we go with exam questions straight today or not. Now, if we go into the actual distribution, kind of like the bell curve, right? You will notice that they actually have 0 here. And then what they also have is they've got a Z value. All right. So what we're going to try and do is we're going to do a couple of really quick examples, and I'm going to show you how to do it. And then I'll get you guys to try a couple, and then we'll actually go from there. Hi, Angelica. Welcome. So we're going to get to the mean and standard deviation, but before that, we are just going to look at the curve itself as is, all right? And let's say we have a question, something like this, and I'm going to start with a really basic one. And this is the one thing you need to understand, right? Like the two graphs that we have here. One is going to be for your real values, all right? And then your other one is going to be, I think it's normal. What do they call it? Like they call it something. Sorry, folks, I haven't done this in a long time. Is it normalized? Yeah, I think it's like just you kind of like make it all as, I don't know, I could be completely wrong. I can't remember it. Maybe not, just like this is probably just called normal distribution. But the key thing is the mean when it comes to the real values, this is going to be real values, and the standard deviation is going to be real. So if you look at, like, say for example, height of people, right? You're on the real side, your height is going to be like average, like the mean is like, say for example, if I say a height, it could be, I don't know, 175 centimeters, and then the standard deviation is like 4 centimeters. Just throwing it out there, right? But a normal distribution, your mean is always 0 and your standard deviation is always 1. All right. So this is something that you need to understand. So when we actually using the tables, particularly the tables on your probability sheet, formula sheet, your standard deviation is always 1 and your mean is always 0. Okay. So keep that in mind. But then when we have real values, it's going to be like, you know, actual numbers. But for normal distribution, it's always going to be 0 and 1. Okay, so what we're going to do is do a couple of quick examples, just looking at how to actually find it when it's like just normal distribution. So let me have a look at this. So I'm just going to put this as set one example, right? So let's say I want to find the probability between 0 and I'm going to go with 1.2, for example. I want to find the probability that what is the probability for this to be between 0 and 1.2. Now, if this, because this is actually already like it's a normal distribution, we just write this as probability of 0 less than z less than 1.2. Now, imagine if this was in the real world. In the real world, what it'll look like is something like this. In the real world, it could look like 175, and then, I don't know, this somewhere here could be like 181, for example. And again, this is hypothetically putting. All right. Now, in this case, the question would look like this. Probability of x between 175 and 181. So what you need to understand is that when we use the real values, we have it as x. But when we use the normalized values, we're going to have it as z. So if you go back to the tables, with the probability tables, what you'll notice is we only work with z. All right, we don't actually work with real numbers. So if you go in this table, your table doesn't have 181, or it doesn't actually have 170, whatever the other number was. Was it 175? Yeah. All it has is along the top, along the bottom, not the bottom, what do you call it? Along the left-hand side, which is all the way along here, it's only going to go up to 3.9. All right. Now, that's because, remember what I said to you earlier at the start, like if you go within 3 standard deviations, you're going to cover 99%. The way I get that, before I do that, actually, no, let's do that. No, I'm going to come back to that one later. Pause on that one, all right? Let's just go and have a look here. So in here, on the real side, I can't actually put in 175 or 181 on the probability table. But what I can put is 0 to 1.2. And again, these are two completely separate examples. I just want to kind of point out there. If I want to find the probability between 0 and 1.2, all I do is I go to the table and I go along this line here until I get to 1.2. And I'm looking for 1.20. And I think if I zoom in enough, you're going to see the probability. That's basically telling me that between 0 and 1.2, it's a probability of 0.3849. So what I'm going to do here is I'm actually going to put this as 0.3849. Now let's say I want to use the calculator for this to try and figure it out. So with the calculator, and again, I know you guys are using the latest, the slightly different model of this calculator. But it still works in this. All you got to do is just go into stat mode, and then you've got distribution. We're going to click on normal, and I think it's NCEA. Now you'll notice it says lower is 0, upper is 0, standard deviation is 1, and mean is 0. This already happens on the calculator. So in our case, we're looking between 0. So 0 is the lowest number. We're going to leave it as 0. And then we're going to go to the upper number and we're going to put down 1.2. And just press equals. And as you can see, you're getting 0.3849, which is pretty much the same answer as I got before. You're welcome, Nature, JSWN. Yes, there's full calculus playlist available on the main channel. Go in there and have a look. I think it's calculus in 10 hours. I'm sure it's 10 hours. But yeah, go have a look. Good luck. Now, the thing is, this is 0.3849, right? Let's go back to the real version. In the real version, we actually had 175 to 181. So if I want to find this with the calculator, what I need to do is, I still need to do the same thing. I'm going to go into menu, and I'm going to go into the stat mode. Let's just exit all of this. I'm going to go into distribution, normal, which is right there, F1. and then I'm going to go NCD. But this time, my lower value is 175. So I'm going to put in 175. My upper value is 181. So that's going to be 181. Now there's these two symbols here. Now if you do get confused, you're like, I can't remember which one is standard deviation and which one is mean. All right. All you have to remember that the mean, it looks like an M right there. It looks like a very skewed little M. All right. It's actually called a mu, and I think the letter is called mu in Greek or whichever language it's in. So that's the mean right there. So standard deviation comes first. So that's going to be 4. And the mean was 175. All right, so now we just press enter and we actually get a probability of 0.3944. A good idea to go with is 4 decimal places in this case. So I'm going to go with 0.3944. How do I do this manually? Like, let's say I don't have a graphics calculator. How do I do this manually? So to do that, you have to convert you know how right now it's in the X formula? You have to convert it to the Z formula. Now, if you forget the formula, don't worry. It's actually in the formula sheet, because right here at the top, it tells you that to find a Z value, you take the X value, you minus the mean and divide it by standard deviation. So if that's the case, I'm going to go here, and so the formula was Z is equal to X minus the mean over standard deviation. Now I've got two values that I need to worry about. I've got 175 and 181. So I'm going to write this as Z is equal to 175, take away the mean, which is 175, divided by standard deviation, which happens to be 4. Yep. And then for the 181, I'm going to go Z is equal to 181, take away 175, divided by 4. So now I've got my two Z values. My first Z value is 0. My second Z value is 6 over 4, which is 1.5. So in the real world, the probability is between 175 to 181. But when it's normalized, we are going to get it between 0. And instead of X, we now write it as Z. And instead of 181, we're going to write 1.5. So what we're looking for is we're going to go into the table and we're going to look for 1.5. So let's go here. 1.5 happens to be right there. Now, what have I made a mistake with? Why am I not getting that answer? Did I type something wrong here? Oh, there it goes. There's my mistake. It's not 180. It's actually 181. There we go. That's much better. I was wondering, hang on a minute. So I should have actually got 0.4332 as my answer. And if I go in here, you can see at 1.5, I'm actually getting 0.4332 answer. So when you are using the graphics calculator, it's a really good idea to just show them even the graph of it, to show that you actually understand what's actually happening, and don't just put it blindly and just get the answer only, because correct answer only gets you, sometimes they get very tricky with it. Eric, yes, we are. I just haven't got through it yet, but I will get to it sometime next week, if that's all right. Okay, so what I'm going to do is I might just give you guys a couple of really quick Z examples, maybe about 5 questions, just to try like different, and the reason, actually, I'll tell you why I give those questions, because I'll try and give you guys all those questions, is because if you understand the basics of this, right, like I know sometimes it's boring to do the same repeat stuff, but the basics, if you crack the basics correct in this, then what happens is that when you get to the excellence question, you will actually understand what the question's asking. I feel out of all the probability paper, getting excellence in the normal distribution question is probably the easiest, at least in my opinion, because I've done it so many times. The probability trees, it's always, you can make a mistake here or there with the language. The two-way tables, no, there's an absolute risk one. Yep, if you have it the other way around, you can make mistakes. But normal distribution, you do it right, you can easily grab that 8 points from that question there. All right, so let's do a couple of really quick basic ones. So I'm only going to do Z ones. And you can use the calculator if you'd like, or you could use the table. Up to you, because I know I can't actually paste the whole table here. But we'll do 5 questions, all right? We'll do 5 questions from set 2. Okay, so we're going to have it between 0 and, let's go 1.7. So I'm looking for that. Yes, Hudson, you will, because you'll basically get the formula sheet. So this is the formula sheet you'll get in the exam paper, in your exams, and you'll have this whole table with you. Where is it on the calculator? So if you click on menu, go into the stat mode, and then once you go into stat mode, you will see distributions, and then click on distributions. Normal is F1, and then NCD. That's the one you want. Now let's do this one. I'm literally going to give you guys all the situations that I can think of that's potentially could happen. I think there's about 9 situations that could happen. Let's have a look. Now remember, folks, for question C, this thing is symmetrical. If it's symmetrical, you can actually find it for 1.3, and it's symmetrical. So it just reflects on the center, on the mean itself. One more. What am I missing? The F. As you can see, my beautiful bell curves, they're all like screwed up everywhere. All right, here's 6 questions, and look, I know you guys know how to use it in the calculator. It's fairly straightforward to do it, but like, try and kind of understand it through the tables, because what it does do is it does help you when it comes to merit questions and excellence questions. So understanding these 6, I think these are the 6 situations that could potentially happen. I'm trying to think, is there anything else? No, I think we've covered everything. Oh, there's a couple of more, but you'll get the idea of it. Hey, Zepto, welcome. So, and again, I'm just going to kind of interrupt here. Remember that these are all like from 0 to the left-hand side is 0.5. From 0 to the right-hand side is 0.5. All right. So if you do get stuck, you can always just go 0.5 minus things as well. So keep that in mind. So I'll give you folks another couple of minutes. And look, if you make mistakes, honestly, don't even worry about it. Just, it's better to make mistakes now, and like no one's gonna kind of even notice. Just, you'll pick it up and you will figure it out. Zepto, yeah, my day was pretty amazing, because to be honest, I was at Howick Youth Council, and I had a chance to work with quite a lot of youth, the leaders from around the neighboring schools. So that was really cool. I enjoyed it. They asked me to talk about social media. I don't know why, because I'm I just don't really think that I'm that big, but like, yeah, whatever. Solving linear equations. All right. Now, since you're kind of here, yes, there is, buddy. Like, I think they are called the MCAT, the MCAT live tutorials. There's a lot of linear equations that I've actually done in there. But the problem is, like, they're like old videos, but they're still, algebra hasn't changed, and I don't think it's going to change anytime soon. There is like a couple of old live streams that you can go have a look at it. Otherwise, the other space you could look at is, I think, in my numeracy prerequisite playlist, there's a linear algebra component just for linear algebra. So that's probably worth having a look there as well, Zepto. Easy. If you can't find it, just give me a yell. I'll see if I can tag it while I'm in the middle of this. All right, people, I think that's enough chatting. So let's just kind of go through this. I'm going to try and see if I can do a little... Oh, you're welcome, Nora. Not a problem at all. All right, so let's do this one. And I think, let me just see if I can grab a copy of this desktop capture. Oh, it's too small, isn't it? I want this table to be a little bit bigger. Yeah, that's something I can work with. All right. So the first one I'm going to look at is 0.7. So if I look at 0.7, I'm going to go right down along z-axis here. And if I look at 0.7, no, not 0.7, 1.7, that's going to be 0.4554. So my answer for the first question, set A, is going to be 0.4554. Ah, nice to hear, mate. Nice to hear. Now, looking at the second question actually says I want it greater than 2, right? Now, remember, these tables, they actually calculate from 0 to z, okay? So if we have a look at 2, we are getting 0.4772. That basically means this area is worth 0.4772. Now, remember I told you guys this, that anything from halfway onwards, so this entire, maybe not this color, so the green part here is actually worth 0.4772. That means to find out what the yellow part is, remember that the yellow part and the green part adds up to 0.5, because, that's what we talked about right at the beginning. So all you have to do is, we're just going to go in the calculator and just go 0.5, take away 0.4772. And there you have it. So the answer for this one is going to be 0. Would help if I used not a highlighter. It's going to be 0.0228. All right, because we're actually looking for z greater than 2. All right, next we're going to have a look at z is between negative 1.3 and 0. Now, remember I told you guys that this is symmetrical, right? So if it's symmetrical, then what I can do is I can kind of put this as 1.3. And if I find the blue area, which is between 0 and 1.3, that's the same, because they're symmetrical in the middle. So the blue area is the same as the yellow area. So all I have to do is just find 1.3 and I'm good to go. So I'm going to go here and let's have a look at 1.3. So 1.3 right there is 4032. So because it's 4032, if the blue area is 0.4032, then the yellow area is also going to be 0.4032 because it's symmetrical. So this answer here is 0.4032. Now looking at D. Okay, wait. I'm going to pause here. Let me know if you have any questions so far. I know I haven't done them with the calculator. I purposely did not do it with the calculator because I know you guys can just punch in the numbers and you'll be fine. So let me know if there's any questions so far with these three. And trust me guys, by the end of this session, we're going to be doing like some basic exam questions and you guys will get the achieved ones so easy. So don't even stress about it. Chuck me a little emoji of something to say we can move on. Yep, perfect. Cool. I got a 100 there. That's nice. Cool. So now what we're going to do is we're going to look at the next three. So if we look at question D, we are asked to find z less than negative 2.1. So what we're going to do is we're actually going to find what this green part is first and then go 0.5 minus the green part. But to find the green part, I actually need to find the blue one, except the number I'm going to use is positive 2.1. All right, so what then I'm going to do is I'm going to go back to my tables and I'm going to look at 2.1. So 2.1 is right there, which is 0.4821. So this blue part is worth 0.4821. Reflective, they're symmetrical. So the green part is worth 0.4821. So that means the yellow part is going to be 0.5 take away 0.4821. And that's going to give me 0.0179. So this probability is 0.0179. Now let's have a look at question E. Question E is asking from 1.1 to 1.8. So I'm actually going to do I'm going to split them again as two parts, right? What I'm going to do is I'm going to do the yellow part first between 0 and 1.8. Then I'm going to do the green part and just add them together. So when I look at my tables, the yellow part, which is 1.8, is going to be 0.4641. So that's this thing here, 4641. Then I'm going to look at 1.1, which is this. That's going to give me 0.3643. And all I have to do now is just add those two values up. So 0.3643 plus 0.4641. And that's going to give me a probability of 0.8284. And finally, we've got it between 1.5 to 1.2. This time, we got to subtract the probability because when I calculate the probability for 1.5, that's the yellow part is going to be all of it. So it's going to include the 1.2. So I kind of need to do something like this. I need to work out what between 0 to 1.2 is first. Then I need to work out between 0 to 1.5 and then subtract it. So let's go and have a look. For 1.5, we've got 4332. So 0.4332, which is 1.5 right there. Then I want 1.2, which is this one, 0.3849. And all I've got to do is I've got to subtract it. So I'm going to go 0.4332, and it's not working. Let's just clear that. 0.4332 take away. And that's going to give me a 0.0483. So what I've done here is I've actually taken the, it's that yellow part minus the green part to get this part here. So this area here is actually worth 0.0483. Now, folks, I know I kind of have done only one decimal place for these Z values. So I'm going to pause here for a second. Let me know if you have any questions. Otherwise, I just need to add a couple of things on. And I realized that I missed one thing. I might have to come back. But otherwise, we'll just do the exam questions tomorrow. By the way, I'm back tomorrow. Not, I know I missed yesterday's because I was kind of behind in my presentation. All right, chuck a emoji up if we're ready to move on, people. Cool. I see a couple. Fantastic. Now, look, the problem here is that your Z values are not always going to be like beautiful one decimal place. Hudson, I will answer that question right now for you because to be honest, there is one whole question that's dedicated to normal distribution. So, I mean, this is last year's exam paper. If we just want to have a quick kind of nosy through it right there. Look at that. That's your first achieved question right there. Like it's opening with it. And if you notice, you've got your mean, which is there, 10.8. You've got your standard deviation, which is 3.2. And they're asking between 6 and 10.8. So all you're really doing is just punching that in the calculator, guys, because you just go menu, you go into stat mode, go into distribution, normal, NCD, and what's my lower limit? In this case, it's 6. Upper limit is 10.8. My mean is 10.8. No, that's my standard deviation. I'm typing it wrong. Standard deviation is 3.2. My mean is 10.8. And there we go, 4332. But I guess the thing that I want to show you guys is, why did I use 0.5? I'm going to come back to that, Elise. Hold on that. So Hudson, like, notice how like the Z value in this case is like 1.406. And that's what I want to talk to you guys about next. But I'm going to come back to answer Elise's question. Elise, which part of the 0.5 are we looking at? Let me know. So Hudson, yeah, that's pretty much how the questions start. And then they'll ask you a question like, if the probability is this, what's the mean or standard deviation? And then they build on with the excellence question. But there's 100% you're going to get at least one full question on normal distribution. If you want to let me know which question you want answered at least, because I'm thinking you're trying to understand why there's 0.5. Is that what you're trying to understand? If you are, just remember, like when you find the average, right, you're basically saying I'm finding the middle of those things. That means 50% of your data is above that average and 50% of the data is actually below that number. So that's why we use 0.5. I enjoyed it, Jack. It was awesome fun. I haven't posted the photos yet. I took some great, your signature selfie photos. Yeah, I've got to post that later on. But no, absolutely enjoyed it. And I'm looking forward to the next visit soon as well. So I don't know if that's been made public yet, but like, yeah. Anyway, now, one thing, Hudson, you might have noticed in the previous, that question that we had was they, sometimes what happens is that your, when you take the number of a 0.5 together, why do you use 0.5? Question B. Right. The reason I used 0.5 is because I want to find the yellow area, right? The yellow area is what the question's actually asking me to find. the tables only give me up to the green area. So if you look at the tables, wherever that is, you see how the table is actually giving you up to that area from the 0 to the Z value. So if you think about it, everything on this side is actually 0.5. So if I want to find the orange area here, I've actually got to go 0.5 minus whatever that black area is to get the orange one. And that's, yeah, I think I might have explained it. Yeah, that's what's happening there. All right, the next thing is this. Sometimes, not sometimes, majority of the times, your Z value is not going to be pretty. What do I mean by pretty? Like, you're not going to get like exactly 1.1, 1.2, or 1.3. Sometimes you'll get something like this. What happens when you get, let's say I'm going to go 1.648. All right. And let's say we want to find the area between 0 and 1.648. Now, this is where things get annoying. They're tedious. And this is why I like using the graphics calculator, because it's just so much faster. The tables are a pain, I'm going to be honest. But in some ways, it's kind of fun as well. Like, I kind of love figuring it out. So how do we do 1.648 on a table? I'm going to get rid of all of this. So if I want to figure out what's the probability of between 0 and 1.648, this is the work that I have to do. I'm going to do a couple of extra steps, so bear with me, all right? First, I'm going to look at 1.6. 1.6 is somewhere here. Then the next value I'm going to look at is 4. This 4 happens to be here. And if I look along the way here, that is what I'm looking at. That's 1.64. So just to give you a bit of an idea, the pink part here is right here, 1.6. The green part is at the 4. And finally, the 8. And this is where things get super annoying and I hate it. The 8 is something here. And if you go all the way down, you're going to have to match it up to this value here, which is an 8. Just going to zoom in a bit so you guys can see it a little bit better. So now what I have to do is I've got to go 0.4495 plus 0.0008, which is going to give me, what is it going to give me? Got a 3, got a 1, and a 0, and a 1, and a 5. So that's going to give me a probability of 0.4503. Now, as you can see, that is quite tedious. It is quite annoying. I would strongly recommend using this. So whenever you want to find something like this, like where you're finding 1.645, I would literally just draw a line like this, just so that I don't mess it up. And I mean, this one is not too bad, like, you know, because you can kind of see it. Stupid 90 degrees. There we go. So that kind of helps me figure out those extra values. Now, if you, again, like if we had this in the calculator, we just go into menu, stat. What is our lower? Our lower is going to be 0. Our upper is going to be 1.645. Standard deviation is 1. Mean is 0. Now, there is a little discrepancy. All right. Oh, wait. Hang on. Did I do that right? 1.645. There we go. Should be 1.648. That's better. Because the discrepancy should be like very little when you have it. Like you won't have it like massive big number changes. If you do that, then you know you've done something wrong and you can always go back and check it. But yeah, so that's pretty much how we do the normal distribution tables. So I think I'm just keeping an eye on the clock here, guys, and I want to show you a couple of quick questions, but we're not going to do all the normal distribution questions today. I just realized I've yapped on for a little bit too long. Apologies. But if you have a look at these questions that are in the exams. So here is the first question. All they're asking you to do is find the probability between Yeah, 6 and 10.8. That's an achieved. Okay, let's go to the next one. The next one, they're basically asking what is it that they spend over 16 hours. Again, Elise, you actually asked, why do we do 0.5? In this case, you would look at 1.625 and then you go 0.5 minus whatever the probability for 1.625 is. And that's how you get 0.0521. All right. You always get at least one or two achieved questions like this in probability for normal distribution. So I think tomorrow what we'll do is we will literally just focus on these achieved questions. And then on Sunday, we'll actually look at some merit questions. So if you look at it, actually, let's go back and have a look. How many? Yeah, see, that's when they have to find X, and I'll show you that later. Probability tree. Yeah, so it's like probability tree, two-way tables, and then they do normal distribution. Ugly probability tree. Just want to find a normal distribution. Yeah, here we go. Another normal distribution question. So they basically start off with, what do we got here? In this case, they've got standard deviation of 35, mean of 113, and they want to ask you for under 92 minutes. Now, all of these questions, when we work on it next time, it's really important that you draw a little diagram just so that you actually understand. And in this case, and in some calculators, and I think the newer calculators, you can actually draw the graph. So I kind of do a bit of a, if you're finding it hard to remember which side to put things on, I mean, trust me, you can always just copy the graph from the graphics calculator as well as a form of evidence that you can show on your exam paper. But other than that, we'll, for something like this, we would simply go into stat mode. Our lower value, in this case, I mean, we could, because we don't know what the lower value is, and I'll talk a little bit more about the calculator hack for that, but I usually put this, I'll tell you why tomorrow. Upper, I'm going to go 92, standard deviation is 35, mean is 113, and there you go. That is, I've made a mistake somewhere. Why do I have made a mistake somewhere? Find the probability, spends under 92 minutes. Hudson, I reckon you could just chuck in how much evidence? Just a little diagram is more than enough. Thank you, Liana. School visits, I gotta look a bit decent, not like a homeless guy, which I tend to do all the time. Now, hang on a minute. Why am I getting this wrong? And why is my probability negative 0.72? Oh, I know why. That should have been a negative. There you go. That's better. 0.2742. All right. So we'll do this a lot more tomorrow, and I'll just get a whole bunch of normal distribution questions for you guys. And Hudson, we'll actually go through some hacks on showing how to show the evidence. All right. And I think that's what I did here. So if you look at last year's paper, they started saying that you need to show some sort of evidence. And that little diagram is more than enough evidence. All right, guys, sorry I didn't get to actually doing the questions today, but I just wanted to make sure we covered all the basics correctly, and we're pretty solid with that. And then tomorrow we will actually go with the normal distribution questions, from the actual exams, so that we can kind of get used to exam questions. All right. Sirateep, yeah, hello, welcome. But apart from that, yeah, that's me today, folks. Thank you for joining. Appreciate it. And I'll see you guys tomorrow. But I'll hang out again. Usually I'll hang out for a couple of minutes. And then I'll call it. Trust me, Hudson. I'm not, man. I just sometimes I just do some crazy stuff. But no, thank you for. I do apologize yesterday, Hudson. I know you were actually kind of waiting yesterday for a lesson, and I just put too much on my plate yesterday, and I couldn't get to my presentation in time, and I was like, oh, I'm falling asleep and I need to make a decision. So, but thank you for joining today, and I'm looking forward to working with you for the next, I don't know how many sessions it's going to be, but we'll get there. Actually, which school are you from, Hudson? You from Auckland or out of Auckland? Yeah, I'm gonna be honest. I've never heard of that college. That's so cool. It's like I gotta ask. Is it like an area school? How many people in your school? Is it like a big school, small school? I always find it fascinating. Fascinating, actually. Menzies College, Southland. Wow, 350 kids. So hang on, I gotta ask you this question. How many people in your level 2 class? Jeez, you only got like three. Yeah, you're right. 361 kids. Because I know, like in some area schools, they don't get to have maths 25 for stats. That's awesome. Are you doing calculus as well, or just stats? Oh, nice, mate. Nice. That's good. That's awesome. I gotta ask, how did you find me? Because it's like, unless people usually, it's like through word of mouth. Did you just look up online for tutorials, or how did you find me? Ah, okay, man. All right, I'm glad to help. Anyway, dude, I'll leave you guys to it. I will see you guys tomorrow. All right, tomorrow we'll definitely go through the achieved questions for probability. That way, at least we know we're gonna nail at least 4 of those points in any exam paper that you guys are gonna be sitting from this point onwards for probability. All right. But the aim is we always go for merit or higher. That's the aim. So yeah, but no, awesome. David, you were quiet today, but lovely to have you. But yeah, I'll see you guys tomorrow, right? Take care and look after yourselves. And as always, thank you for watching. Oh, happy to help, Carter. Happy to help. But yeah, see you guys tomorrow.